Hello and welcome to this tutorial which will show you how to subtract fractions with borrowing. You need to have a good understanding of subtracting and adding fractions normally and be able to convert fractions to an equivalent fraction with ease. If you've got both of those, then you're ready to go for this. Let's do it! Now let's start with this subtraction of 5 1/5 taking away 2 3/5. There's two ways that we can do this, and the first is to have a go at borrowing from the whole numbers. As you can see, we've got 5 1/5, subtract 2 3/5. Now, a 3/5 is going to be difficult to take away from only 1/5. To make this easier, I'm going to take one of the wholes away from the 5 and give the 5/5 of that over to here. So we can turn 5/5 into 4 6/5. It's exactly the same amount as the 5 1/5, and that makes the subtraction of 2 3/5 an awful lot easier. I can take the 2 away from the 4, which would leave me with 2, and I can take the 3/5 away from the 6/5, which would leave me with 3/5. So just to be clear, we split the 5 units into 4 units, and we took 5/5 away from that unit and put it into the 1/5 to make 6/5 altogether. The second technique you might do is turn the mixed numbers back into improper fractions by using your times tables. And since we're dealing with fifths, you would use the 5 times tables. So I know that if I was to multiply the 5 wholes by 5, I would have 25/5 to add to my 1/5. So 5 1/5 is the same as 26/5. And I'll do the same with the 2 3/5. 2 times 5 gives me 10, and if I add the 3 to the 10, I will have 13/5. And then taking away the 13/5 from the 26/5 is easy. I will actually be left with 13/5, much like I was in the first method, which I can then turn back into a mixed number, which would give me 2 3/5, exactly the same as what we saw before. Now here's a bit of an extra challenge. We've got 4 1/3 subtract 3 5/6, and we've got to do an extra step to work out the answer to this. We'll need to convert one of the fractions, and the fraction to convert is the third, so that we can turn it into sixths that we can then compare with the 3 5/6. So 4 1/3 is the same as 4 2/6, and we can then consider taking away that 4 2/6 from the 3 5/6. Okay, so let's use the borrowing method to give ourselves some more 6 to take away the 5/6 from. The 4 2/6, I'm going to separate that 4 into 3 wholes. I'm going to take 6/6 from the 4, so that I've now got 8/6 to subtract from the 3 5/6. I'll take 3 away from 3, will leave me with nothing, and if I take 5/6 away from 8/6, I'll be left with 3/6, and hopefully you'll see that is a half as an equivalent. I'll very quickly turn the question also into 2 improper fractions. If I multiply the 4 by 6, I'll have 24. If I add the 24/6 to the 2/6, I'll have 26/6, from which I can subtract 3 5/6. 3 times 6 is 18. Add that 18 to the 5/6 gives me 23/6. If I subtract 23/6 from 26/6, I will have 3/6, exactly the same. Half is an equivalent fraction for it. Time for you to pause the video now and have a go at using the technique of your choice for yourself. The first 2 have got mixed numbers with common denominators, so no conversions are necessary, but 3, 4 and 5 are a little trickier. Do your best, have a go, and we'll see the answers in a moment. Here are your answers. So we've got 6 1/4 take away 2 3/4. If we borrow 4/4 from the 6, it becomes 5, and we'll have 5 quarters over there. We can take 2 3/4 away from there, which will give us 5, and 2 quarters, which is the same as 5 1/2, of course. 4 2/7 we can convert to 3 9/7, and we can take 1 6/7 away from that, leaving us with 2 3/7. Now the first one is a conversion. We need to convert the second fraction actually to 1 4/6. Now once we've done that, we then need to take the 5 1/6 and take 6/6 from the 5, so we'll have 4 units and 7/6 that we can take 1 4/6 from. And if we do that correctly, we'll be left with 3 3/6, or 3 1/2 if you prefer. 7 2/9, we need to convert the 7 2/9 into 7 4/18, and then we need to transfer 18/18 to the fraction over here. So 4/18 becomes 22/18, along with the 6 wholes. From that we can take 15/18 away from 22/18, which will leave us with 7/18 and 3 wholes once we've taken a 3 and a 6 away. And then 5 3/5, straight conversion to 5 6/10, but then we need to turn the 5 6/10 into 4 16/10, from which we can take 9/10 away. That will leave us with 7/10 and 2 wholes. That's the end of the main part of the tutorial, but if you'd like a little bit more torture, then hold on, and you can do a little bit more and go a little bit further with this. But well done for getting this far. Now we need to take away 1 3/5 from 3 1/4, and what's difficult about this is that quarters and fifths aren't really well related. So we have to convert both into a denominator that can be in both times tables. Now the first multiple of each time of both of these times tables is 20. 20 is in the 4s and it's in the 5s. Now if we convert the quarters into something over 20, I need to multiply by 5. And conversely, if I need to convert the 3/5 into 20ths, I need to multiply the fraction by 4. You can see the symmetry going on there. So 1 multiplied by 5 is 5. No problems there. And the 3 multiplied by 4 is 12. So if I update the mixed number, 3 1/4 is the same as 3 5/20. I'll take away 1 12/20 from it. Okay. Next, I need to borrow from the whole number, so that I can take. So I've got enough 20ths to take 12/20 away. So much like I did before, I'll take 20 20ths from the 3 wholes. So I'll be left with 2 wholes and 25 20ths. I'll take the 1 away from the 2, which will give me 1, and I'll take the 12 20ths away from the 25 20ths, and that will leave me with 13 20ths. We can't simplify the fraction anymore, and that is your final answer. Pause the video one more time and see if you can get your head around this. Which multiple is in both the 3 and the 7 times tables? That will help you out. Okay, let's do this. So, if you've thought about it, the multiple that is in both times tables, the common multiples, is 21, isn't it? So we need to make fractions that have a denominator of 21. And to do that, we need to multiply the 3rd by 7. And we need to multiply the 7th by 3. There's that symmetry again. So 1 times 7 is 7, and 5 multiplied by 3 is 15. Let's now bring down the whole numbers. They don't change. 6 and 4. And then we need to borrow from the whole number, from the 6 to add to the 7/21ths. So if I do that, I will have 5 wholes, and I need to add 21 to 7. So I'll have 28 21ths, from which I can subtract 4 and 15 21s. And if I take 15 away from 28, I'll be left with 13 21s. That will be your answer. If you've got that right, you've done some incredibly insane and brilliant maths. Well done.